Oh, okay, so I'm just making a video here, just to give you an idea, an example of for the science project. One of the body systems you can choose is a model of the lungs, and here's a poster that I made last year. I did this for the first time last year, and I actually made two posters in the time allocated just to give you an example. And now we're in remote learning. I'm asking you, rather than present this as an interactive poster to some primary school kids, I'm asking you guys to make a video to show me what you've done and explain how it all works. So I've got the model of the lungs here, and I just want to deal with this side of the poster first, and then I'll go over and talk about what's happening there. So if you can see, similar idea to the digestive system here. You've got the esophagus, that's always sitting behind the trachea, and in the black pipe here, what I've done is I've got a section of, I think it's washing machine pipe. It's kind of bendy, flexible kind of stuff. And if you feel your trachea, you can actually feel those little rigid ribs of cartilage in there to support the structure. Now, like I've got here, I've got a little stopper, reusing that idea here, using this as an epiglottis that closes over to protect your windpipe when you swallow food or drink liquids or stuff like that. So when you're breathing, that's open, of course, that's open. So why don't we take that out? And we've got the trachea branches off into what's called the bronchi, these two large tubes here that just one basic thing here is that this branching is often splitting off into two. And I'm following that through here as I build my model of the lungs. What I've got down here, if you can see, is some smaller tube here. Again, just cable tied on, and it's always branching in two. And I've just stopped that branching there. These are the bronchioles. As they get down to smaller and smaller tubes, eventually they'll terminate in the alveoli here. And all I've done is cut one of those spheres of foam into two and use some of the orange bag material to cover those, because these air sacs, they're surrounded by beds of capillaries that help with the exchange of oxygen and carbon dioxide across the surface of these air sacs, okay? And that's how, as you breathe in, you bring all this oxygen-rich air into your lungs, and that allows the oxygen to diffuse into your blood. And when you exhale, there's a lot of carbon dioxide that needs to be expelled. So as you breathe in and out, you're going to exchange those gases. And I think with every normal breath in and breath out, you exchange about 1/6 of the volume of your lungs. So I've got some bubble wrap here just to reinforce this idea that your lungs are like tiny little air sacs, and we've got these little bubbles in here to represent those little air sacs. And I've just sort of roughly shaped the lung like this because up here, people forget that your lungs actually extend into the top of your chest here. And, you know, if you break a collarbone or something, you could perhaps rupture the very top of your lung up here if that bone drives down into your chest cavity. So all that's there. And what we're talking about that, we didn't explain, there's a couple of things missing from this diagram. And one of those is a rib cage that helps protect the lungs. Okay, And as you breathe in and out, you might be aware that your chest cavity expands and contracts. And the other thing that's missing from this diagram is the diaphragm down below your lungs, because if you dig your fingers in under your ribs, under here, as you breathe in and out, you can feel, as you breathe in, that muscle pulls down, drawing all the air into the lungs. And as you breathe out, you can feel that muscle go back up to help push the air out. So that's missing. And also what's missing here, we're talking mostly about the lungs, but the heart is a really important part of that system, because it's shunting blood. Once all the blood returns to the body, it's shunting that blood to the lungs to exchange the gases. And then once that job's done, all this blood in the capillaries needs to find oxygen-rich blood, needs to find its way back to the heart. So that's why I've got these straws here to represent what's going on. And some information here to help you understand that. And that might be a bit blurry on the screen, but I'll just quickly read what it says. Blood returns to the heart by the superior vena cava, which is a blue straw. The heart pumps blood through the pulmonary artery, a red straw, and blood perfuses to the lungs through the capillaries that surrounds the alveoli, so I've got them there. And then the oxygenated blood returns to the heart through the pulmonary vein. That's one of these blue straws here. And leaves the heart again through the aorta, which is a red straw, to be pumped around the body. So I've got my explanation there. Let's move on to the other thing I was thinking about in this poster here, was trying to explain what happens to your lungs if you don't look after them, if they get full of dust or any of those sort of things. So normally, here's a cutout of the trachea. I've got these pipe cleaners in here. There's these little finger-like projections in there that are always beating up, and they're always carrying like the phlegm and all the rubbish that does get into our lungs, always carrying it up, and we often feel that in the back of our throat, and then we cough it up and spit it out. So I've just got here, look inside and see the damage that polluted air can cause. And it's all about this message up here to wear the protective equipment to have that barrier to prevent all that dirt and all that junk getting into your lungs. And all I've got here is just a cover of someone's diary that they've left in the science lab and abandoned, to represent all the dirt and everything that can get into your lungs. And over this side, we've also got to think about all the toxic chemicals that we can breathe in, where this mask won't do that job of removing the toxins from the air before we breathe it in. But there are masks out there with better filters that filter out a lot of the chemicals before they reach our lungs and damage our lungs. So, and the final part of my poster, I'm always thinking about what happens to your lungs when you're diving. And air is one of those, is compressible. So as you dive under the water, the volume, when you take a breath in, if you're free diving, for example, you take a breath in and fill your lungs up, and you dive down. So every 10 meters or so, it's equal to 1 atmosphere of pressure. And what that will do, if you're holding your breath, that pressure will reduce your lung volume by a half, okay? And I've got this syringe here just to help explain that concept. If you fill it up with air, put your thumb over the end, and you can feel the pressure building up as you compress the air, and you can feel it actually getting hotter on the end of the nozzle there where your thumb is. But there's something on the poster that you can play around with and see that for yourself. So they're the kinds of things that I put on the poster as a sort of interactive part of the display where you can investigate what we call Boyles Law, the relationship between pressure and volume of a gas. Okay, so there's my model of lungs, and hopefully I've explained what my thinking behind that model, and given you a few ideas to build your own. Okay, good luck.